C++, performance and control without compromise. Agenda: Systems Programming Languages. C++ History. Why C++? Compilation lifecycle. Getting started. Basic workflow. Building and running. Systems Programming Languages. A systems programming language gives you direct control over memory, hardware, and performance, with little standing between your code and the machine. If a program needs to meet a strict deadline or run within a tight memory budget, systems level control lets you meet it precisely. Almost every operating system, game engine, and embedded device is built on some kind of systems language. Any team building performance critical software needs a language that doesn't hide the cost of what it's doing. Accepting whatever overhead a managed runtime adds doesn't scale down to every environment. High level and systems level languages. A high level managed language trades some control and performance for safety, portability, and developer convenience. A systems level language like C++ compiles directly to native machine code, giving the programmer explicit control over memory and resources. High level Python, Java, C Sharp, systems language C++, C, Rust. Problems without systems level control. Garbage collection pauses are unacceptable in real time systems like audio engines or flight control software. A managed runtime's memory and startup overhead doesn't fit on constant embedded hardware. Hard to control exactly how data is laid out in memory when performance depends on it. Extra abstraction layers make it difficult to talk directly to hardware or an operating system's kernel. Every allocation and object carries hidden runtime cost that adds up at scale. Misses out on the fine-grained performance tuning that game engines and high-frequency systems demand. The C++ systems language source code is written in .cpp and .h files and kept in a source or Git repository. A compiler translates that source directly into native machine code for the target platform with no virtual machine involved. The programmer manages memory explicitly, aided by RAII and smart pointers instead of a garbage collector. Other similar systems languages: C, Rust, Zig. C++ advantages: compiles to native machine code with no runtime or garbage collector standing in the way. Gives fine-grained control over memory layout, allocation, and object lifetime. Zero-cost abstractions mean high-level features cost nothing you didn't already ask for. Templates enable generic, reusable code that's still resolved entirely at compile time. Runs on nearly every platform from microcontrollers to supercomputers. Decades of mature libraries, compilers, and tooling across the entire industry. Everything is deterministic, almost. One huge benefit is that in C++, Almost every object's lifetime is deterministic. You know exactly when it's created and destroyed. RAII tries resources cleanup to an object's destructor. So files and logs are released automatically and predictably. Smart pointers like unique underscore PTR and shared underscore PTR manage memory without needing a garbage collector. There are no hidden pauses for garbage collection, interrupting a time sensitive program. What you don't use, you don't pay for. The language avoids forcing cost onto code that doesn't need it. Classes and templates. Classes bundle data and behavior together into a single reusable type. Templates write generic code that works with any type, resolved at compile time. Main.cpp. Every C++ program starts execution from a single main function. RAII and smart pointers. Here a smart pointer automatically frees its memory when it goes out of scope. History created by John Stroustrup at Bell Labs, starting in 1979 as C with classes. Renamed C++ in 1983, adding object-oriented features on top of the C language it extended. First standardized by ISO in 1998, giving the language a stable, portable specification. C++11 in 2011 modernized the language significantly, adding more semantics, lambdas, and smart pointers. Continues to evolve on a regular release cycle with C++20 and C++23 adding modules, concepts, and coroutines. Why C++? Performance compiles directly to native code with minimal runtime overhead. Control explicit memory management and predictable deterministic object lifetimes. Zero cost abstractions. High level features that cost nothing you don't use. Portable. Runs on nearly every hardware platform and operating system that exists. Mature ecosystem. Decades of libraries, compilers, and industry tooling. Foundational. Still the backbone of operating systems, browsers, and game engines. Header files and translation units. A.cpp file and the headers it includes form a translation unit compiled independently. Header files declare interfaces, so multiple .cpp files can share the same types and functions. Include guards or hash pragma ones stop a header from being processed more than once per file. The linker later combines all the separately compiled translation units into one executable. C++ compilation lifecycle hash include expands, preprocess, G++-C compile, G++ objects link ./a.out execute. Source is preprocessed to expand, includes macros, compile to object code, linked into an executable, and finally executed by the OS. Getting started with C++. This leads us to the three steps that turn source into a running program. G++-C translates a .cpp file into an object file, G++. Combine object files into a single executable. /a.out execute the compiled program. Basic workflow. Author a C++ file for a hardware unit, for a game design, possibly, and execute. Observe, feedback, optimize. Compiling, linking, and running. Some call compile, link, and run C++ everyday loop. Fast. Modern compilers optimize aggressively while still compiling quickly for iteration. Build systems like CMake manage flags, dependencies, and platform differences for you. Static analyzers and sanitizers catch memory bugs before they ever reach production. Unit tests run natively, often with no runtime overhead beyond the test code itself. Supports many workflows, embedded firmware, game engines, high frequency trading, operating systems. Works the same, source for source, on nearly every compiler supported platform. Any questions? Thank you.